Alright guys, today we are going to talk about, we're going to continue talking about our tables and graphs from last week, from prior lessons here, but we're going to have some word problems mixed in, and we're going to have to build some expressions and equations based off of those word problems, so you'll get to see how they're all interlinked together. We do have one vocab word, and that one vocab word today is the word equation. So equation, everyone? Okay, and your book says that an equation is a mathematical sentence that contains an equal sign. All right, so the little box off to the right, go ahead and, I just have a little example, simple little equation, 3 minus x equals 1. Okay, so here's what we're going to do is go ahead and grab your book, flip over to page 39. Take out a piece of graph paper. All right, on that paper, first and last name. Don't forget to put your period. You can put the date if you want. List down the page. You can put the problems you need to do along with the assignment number if you'd like. Okay, we're only going to do a couple different type of problems today. We're going to start with one that's a little more simple, and then another one that expands a little bit more. So let's go ahead, and the first type of problem that we're going to take a look at is problem number 2 in your book. All right, number 2. Let me go ahead and try to fit the book under here. Okay, I do want to point something out on number 2. Make sure you read directions, because a lot of these problems, they're going to ask you to do more than what appears to be right here, all in the directions. So it says copy and complete each table, then state the domain and range of the relation. All right, so first off, when you're building a chart, if you want to make it that pretty, you can. You don't have to. I'm going to go ahead and just build like a little XY coordinate table here. And it says it just has our x coordinates 2, 4, 6, and 8. Okay. So if I take a look, you have a little word problem up here. It says Bob spent 5 more than 3 times what Anna spent. Okay, so what we have here is we have x, which is what Anna is spending. So you might want to, when you're building this, kind of make a little note to yourself. X is how much Anna is spending. Okay, Y is what Bob is spending. Now, what I'm going to do is I'm going to take this here. Bob spent 5 more than 3 times what Anna spent. So I know that Anna spent, we can use the variable X of what Anna is spending. It's saying that Bob spent 5 more, that means plus 5. Then the 3 times what Anna spent. Well, if Anna spent that much, I'm going to work backwards here on writing this expression. 3 times of what she spent was 3x. 3 times of what she spent. But remember, it's not just 3 times, it's 5 more than the 3 times. Okay, so that is really good that once we get this, we're going to definitely want to write that expression. So, what we have is if you're going to count these as steps, I'd say step 1 is rewrite your table here. Get it ready to write on and record your answers. Step 2 is if they're giving you a word problem, write that expression down. Okay, you're going to see me use that expression throughout. Okay, so to be able to fill this chart out, I'm going to go ahead and do step 3, and that is I'm going to fill this out by using the x coordinate. So what this is saying is what happens, how much does Bob spend if Anna spends $2? So here's how I do it. I plug in $2 for what Anna spent and then simplify. So that's 6 plus 5, which gives us 11. So she spends 2, Bob spends 11. I can use this expression the whole time. So here we go. What if Anna spent $4? So 3 times 4 is 12. Add that with 5, and you get Bob spending $17. How about if she spent $6? $6, I plug in for the x. So that's 18 plus 5. That gives Bob spending $23. And what if she spends $8? $8, I'll plug in for the x using parentheses. That's 24 plus 5, which means Bob would spend $29. So I can box this in if I want like this. It doesn't really matter. Okay, so don't forget, we'll go ahead and consider this step 4. All right, don't forget the domain. And remember, domain are your x coordinates. So I'm going to go ahead and label them least to greatest here. 2, 4, 6, 8. And we can consider this step 5. We go ahead and write down our range. And remember, our range is our y coordinates. So our y coordinates are 11, 17, 23, and 29. All right, so that is problem number 2. So on your homework, you are to do problem number 4. So here you go, problem number 4. All right, go ahead. I'll give you guys a couple of minutes to do that, and then I'll check in with you. Okay, problem number 4. I'll move this up for you, which you probably have your own book. 2 minutes, go. Okay. All right, 30 seconds. Go ahead and turn to your neighbor. Make sure you share your expression, okay, and then share your domain and range. If those don't match up, then you could take a look at your work along with your chart. So share your expression and then your domain and range. All right, 30 seconds. Go. Okay, so for number 4, it says copy and complete each table, state the domain and range of the relation. So it's basically exactly what we did for number 2. All right, so this one is, it just says each ticket costs, or I'm sorry, each ticket to the school musical costs $8. So what I'm going to go ahead and do is I'm going to start with step 1 like it says up here. I'm going to go ahead and build my table really quickly. So I have 4, 7, 9, and 12. And they say up above, those are the number of tickets. The number of tickets sold. Okay? And the Y is the total amount of money spent. So if I'm going to go ahead and do this, the expression, it says each ticket to the school musical costs $8. So I mean, obviously if they spent, if they bought 1 ticket, it's going to be $8. If they bought 2, it's 16, right? If they bought 3, it's going to be 24. So bottom line is you take the number of tickets, which in this case is X, and you're just going to multiply by 4. I'm sorry, by 8. I'm already getting ahead of myself. By 8. Okay? Fairly simple expression. 8 times the number of tickets, because each ticket costs $8. So this is pretty easy, right? So if I just show my work, plug in my 4, that's 32. Plug in my 7, that's $56. If I buy 9 tickets, it's $72. If I buy 12 tickets, 8 times 12 ends up being $96. Okay, so making sure that I write my domain, you should have written domain being all your X's. It's 4, 7, 9, and 12. Your range would be your Y's, so it's 32, 56, 72, and 96. Okay. So there's my table and my domain with my range for number 4. Alright, so let's go ahead and try one more problem. It's very similar, but it's going to be a little longer, a little more to it. And so let's go back, and these two, of course, sandwich problem number 3. Let's take a look at number 3. Okay, I know number 3 is not your homework, but it is part of the guided practice that we're going to do together, because you'll have 1 or 2 of these on your homework. So here we go. It just says multiple. The book says, let me move it up a little bit, multiple representations. It says there are 16 ounces in 1 pound. Okay, so I would say, okay, well, what if there are 2 pounds, right? Or what if there are 3 pounds? Okay, so what would you do? Well, you would just take, of course, and multiply. You would multiply the this, of course, by 16. So what I'm getting at is because I'm looking here at if I'm looking here, it says make a table, or I'm sorry, write an equation that can be used to find the number of ounces in any number of pounds. All right, so what we're going to do is we're going to represent this by an equation. Okay, so I'm going to go ahead and this is 3a. Okay, I'm just thinking about this. If I use the 16, I want to be able to multiply 16 by a number. Okay, so in this case, what if I multiply by how many pounds? Wouldn't that give me the number of ounces? And instead of O, I don't want it to look like a 0, I'm going to use Z. So for example, if I take 16 and if it's 2 pounds, right, 16 times the 2, Z is going to be 32 ounces, right? Or 1 pound, right? It just says earlier 16 times 1 is going to give me 16. So what I'm going to do is I'm going to go ahead, and that is, of course, says write an equation that can be used to find the number of ounces. So that is 3a. Okay, 3B, it says make a table. I'm going to move the book to the side here. Hopefully you have your book in front of you. It says make a table to find the number of ounces in 5, 8, 11, and 13 pounds. All right, so here's what I'm going to do. I'm going to go ahead and build this X and Y chart, just like we did up here. And I'm going to let the X equal the pounds, and then I'm going to let the Y equal the amount of ounces. So what they said in that problem was, what if we have, the first one was 5 pounds? Or what if there were 8 pounds? Or what if there were 11 pounds? What if there were 13 pounds? Okay, so you're going to notice that the steps are going to be pretty much exactly the same as before. That's why I'm not writing steps down. So I can record everything in here. So here we go. If I use this equation, I can go ahead and put Z equals 16P. So I'm going to go ahead and plug in for P of 5. And these are going to be my ounces, right? So I can use a calculator for this just because it's going to be simple calculation. I still need to show my work here by recording my answers and building my chart. So it's 80. So if the pounds were 5, the ounces are going to be 80. Okay, I can do it again. So what if it says the pounds were 8? 16 times 8 is 128. So Z equals 128, so the ounces are 128 ounces. Okay, what if they were 11 pounds? How many ounces is that going to give us? So 16 times 11. So we end up with Z, or the ounces, being 176 ounces. And then last but not least, Z is equal to 16P. So I plug in my last one, which is about 13 pounds. So I'm going to go ahead and punch in 16 times 13 equals, ounces are 208. Okay. So for 3B, it says make a table to find the number of ounces in 5, 8, 11, and 13 pounds. There it is. So that's the table we're looking for. So the last one, but not least, is 3C. And it says, this is the graph. It says graph the ordered pair for the relation. So here's the thing. I am not expecting anybody to make a graph going up to 208 by ones. Okay? So sometimes the best way to do this, you want to get it as big as, or you want to get it as detailed as possible without working on one graph for an hour. Okay, so, or without, well, let's just do this. All right, so if I have this here, the first thing I want to do, what if I did it by, now remember, I'm going by 208. And remember, Y is our ounces, X is our pounds. So what if I go through,
please come to the Rayburn office. Kylie Diaz, please come to the Rayburn office.
What if I go through this, and this is 0, of course. And let's say let's say I go by hundreds. Well, if I go 100, 200, I'm gonna have to squeeze everything into this little spot. That wouldn't make sense. If I go by 50s, it'd go 50, 100, 150, 200. That might not be too bad. Let me see, like maybe, I don't know, 25s, 25, 50, 75, 100. 125, 150, 175, 2. I could do by 25s. I think I shortened myself a little bit here though. So maybe I'm going to go by 50s in this case. So 50, the next main line is 100, 150, 200, 250. Okay. Now, consider I'm looking here. Maybe I don't go by ones. Maybe I can go by, I don't know about fives, because then I'm squishing in. The biggest one is 13 on my x-axis. 5, 10, it'd just be right all in here. So why don't I spread it out? Let's just go by twos maybe. So 2, 4, 6, 8, 10, 12, 14. That's not bad. Okay, of course all my odd numbers are halfway in between. So here it is. When x is 5, so 5 is right here in the middle, y is 80. So 80, halfway between 50 and 100, of course, is 75. So up above that just a little bit, I'd plot a point right there. When x is 8, so it's right up this line, y is 128. So halfway between 100 and 150 is 125. So it's just a little, just a tad above that. When x is 11, so I go over to 10, x is 11, so it's halfway point. Y is 176. Well, I go up here. This is 150 and 200. I know right in between is 175. I could pretty much dot 175 because 176 is going to pretty much look the same. And when x is 13, so it's halfway between, y is 208. So it's just going to go right. Here's 200. 208 is halfway between is 225. So it's a little closer to 200 than 225. I'm going to plot my point there. And there are my graphed points for 3C. Okay? So on your homework tonight, those are the two different type of problems that you're mainly going to see. You might have a few that ask you a couple of little questions besides those, but for the most part, that is your lesson for tonight on words, equations, tables, and graphs.